And so we have a basic logic widget. This if and this else. This is the condition being tested. If it's true, if the player's guess is the same as the number, this will happen, and this will not happen. But if this is false, and it's not the same, if it's greater than or less than, then this will be skipped, and this will not happen, and instead, the else will happen. And let's test the conditions. So first, we'll guess it, and it tells us you guessed the number. So it performs as expected, and let's say we give it something different. And again, that little bit of logic performs as we expect it to. Now let's say that we wanted to give a little bit more complex decision to this process, this little game that we're playing. What we could do is further, branch off or add another if-else decision structure and nest it inside the else in this block. And this is, it's known as nesting. But again, let's say we want to figure out, is the number greater than or less than the player's original guess? So I'm just going to add if and else, and I'm going to use indentation here so you can see where the if and the else belong. So, alright, so now you can clearly see that this if and else block will only happen, or can only be reached, if this test out here is false. And the way it would work, or the order in which it would be evaluated, is it will test for equality. Is the player's guess evaluate to the number? If so, this happens, and none of this would ever happen. That would just be skipped over. On the other hand, if it's not equal to, if this is false, then the else block will happen. So it's going to display, sorry you did not guess the number, and now we have another if-else decision in here. And let's say we'll test for whether or not their guess was greater than or less than. So again, we want to say player guess, and if it's greater than the number was smaller. And so we'll give them a clue. If their guess is greater than the number, then the clue that we'll give them is but if not, if it's neither equal to nor greater than, the only other possibility is their guess was less than. So we'll tell them the number was larger. And let's test our three possible logic conditions. Either they guess it, or it's bigger, or it's smaller than the number. And we know in this instance that the number is 7. Okay. So let's rebuild the project. And let's run. And let's guess the number 10. In this case, we'll fail the first part. So it goes to the else block. It tells me, sorry, you did not guess the number, and then tells me the number is smaller. So let's run it again, and this time instead of 10, I'll enter 3. Because I know that the number is bigger. It's actually 7. Again, did not guess the number was larger. And run it once more, and this time we'll give it 10, and you can see that if we'll give it 7, and you can see that if I guess it right on, it's just going to execute the else block up here, and this else block, as well as its nested if else, will be skipped. It will never happen. So if I put 7 in there, it just tells me I guessed the number. Okay, so hopefully that kind of illustrates some of the basic properties of if and else and of nesting. In addition to doing it this way, again, I could have also said, since there's only 3 logic states, I could have put this on this same level without nesting, and were I to move these braces out here and move this in here, indent over a little bit, and we won't need this outer brace anymore. I'm going to get rid of that, and then we get rid of this. This is just another way of doing something similar, the same thing, but again so if it's equal to, they guess it, and if not, we tell them else if the number is smaller. Well, if it is not equal to it and it's not greater than, it must be less than. So this would be using if, else if, and else at the same level, right, without nesting. Nesting a lot of times gives you, for more complex decisions, you may have a dozen different levels or more of nesting, where you want one thing to happen on the condition that something is true or something else evaluates to be a certain value. So just sort of the basics of if and else and the way that would work. Remember, an if statement tests for a condition inside parentheses. If the expression or condition is true, then the code is executed directly below it in curly braces. If not, it goes to an else if, where another test is performed. And finally to an else, where if none of the other conditions are met, the else is executed. A simple if-else structure begins with if, the condition to test, and the code to execute if that condition is true. If the condition is not met, it goes to the else block, also in curly braces, and then that code would be executed. You can test complex logical expressions in the condition part of an if-else statement. These conditions can be both logical and comparative. Here's an example of some comparative operators. Greater than, less than, evaluates to, or the test for equality, and a function like equals could all be used to make comparisons. Comparative expressions could test if x evaluates to y, or if x is greater than y. Or even more complex structures are function calls, such as does the string name equal Charles. Here are some logical operators. There's AND, represented by two ampersands, which means both sides must be true, or represented by two pipe symbols and only one side has to be true, and NOT, which negates or reverses an expression. Here are some logical and compound expressions. In the first, we're saying if x is not equal to 10, then the code in braces would execute. Here we're saying if x is greater than y and y is less than z, the code in braces would execute. Both sides have to be true with AND. Finally, here we're calling a function equals, and we're saying if the string name equals C Germany, or x is less than y, then the code in braces would execute. With OR, only one side has to be true.